still section 5.5. We were solving absolute value inequalities. Yesterday our focus was just on the and type of problems. What inequality were we given that we knew was always going to result in an and?
Less than.
Less than or less than or equal to. And we use the silly saying less than to help us remember that less than is and, right? Now today you're going to see the or problems. The ors have the symbol or use the symbol greater than or equal to. So on the top of your notes, if you haven't already, let's title your notes Solving Absolute Value Inequalities. Solving absolute value inequalities. When you're solving these absolute value inequalities, you're looking for the symbols greater than or equal to. When we see those symbols, we know that we are going to be working with an or compound inequality. An easy way for me to remember this is I say great or than. Great or than will help me to know that it's an or. So you might want to jot that little silly saying down into your notes. Great or than. I know that's not how you spell greater, but it's something silly to help us remember. Great or than is an or. And again, this only applies to absolute value inequalities. Just like yesterday, we will have absolute value bars. We're going to have to consider two cases where one's going to be positive, one's going to be negative. Now this time we're not looking for overlap, are we? On ors, we don't look for overlap. We want all the possible solutions. We want to know where could we have solutions. Not necessarily where they overlap, although they could overlap. So let's look at some examples. Here's our first one. It says the absolute value of x is greater than or equal to negative 5. So in other words, the distance from 0 is greater than or equal to negative 5. So I want to know how many units away from 0 can I be greater than or equal to negative 5? Well, let's solve. Is this going to be an and or an or problem? Or, and we know that because of the inequality symbol. So let's start by writing the word or. And then on either side of that word or, we're going to set up our two inequalities. So the first one, x is greater than or equal to negative 5, or x is less than or equal to a positive 5. Just like yesterday, we're going to change our symbol and our sign. Let's graph on our number line. Let's include numbers all the way from negative 5 to positive 5. So we have greater than or equal to negative 5. We have less than or equal to positive 5. Now we've got to make a mental set change here. We don't care about overlap, do we? We don't care where they share solutions. We want all the possible solutions. So if we were to take those two individual graphs and we're going to combine them as one, or put all of our solutions on one graph, what would it look like?
Wouldn't it be all numbers?
Why would it be all real numbers? Our solutions could start at 5 and go to the left all the way as far as we can go. You could start at negative 5 and go to the positive direction to the right as far as we can go. Is there ever going to be a number that's not a solution? There's not. Okay, so we would say this is all real numbers. Now you do need to draw a graph that indicates all real numbers. I'm just going to draw a solid line all the way through with arrows on both sides. That is needed. You've got to tell me what a graph looks like that has all real numbers. I want to know that you know that. And of course we do need to state the symbol all real numbers to show that any number will make this inequality true. Any number we put in will make it true. And that seems to make sense. If we put a positive number here in for x, like 8, if I take the absolute value of 8, is that greater than or equal to negative 5? And what if I put a negative number like negative 10? The absolute value of negative 10 is greater than or equal to negative 5. What is the absolute value of negative 10? 10. What if I put 0 in?
Yes.
Is the absolute value of 0 greater than or equal to negative 5?
Yes.
Yeah, because when we take the absolute value, what's going to happen to that number? It's going to turn positive. But isn't any positive number or 0 bigger than negative 5? So that's why it's all real numbers, because we can put anything we want in for x, and you're still going to get out a positive number, which is going to make the inequality true. Put this one. Solve the inequality, then graph the solution set. So the absolute value of m plus 2 is greater than 11. Is this and or? How do we know? Or than, so I'm going to write or. Let's set up our two inequalities. M plus 2 is greater than 11, or m plus 2 is less than negative 11. We can subtract 2. M is greater than 9. Here if we subtract 2, we have m is less than negative 13. Let's put these on a number line so we can see our solutions. I'm going to go every odd number when I write my number line. Sometimes if you have numbers that are spaced fairly far apart, you can go every odd number, every even number, or go every third number, whatever the case may be, so that you can get no answer. As long as you're going by equal increments, you should be fine. So let's graph. We have greater than 9, and we have less than negative 13. Would this indicate a no solution like it did yesterday? Why? Why was it no? Let's back up. Why was it no solution yesterday? They didn't overlap. Yesterday we were focusing on our ands. We wanted to know what number satisfied both conditions, this and that. Is that the case today? Do we care where they overlap or where they share the solutions? No, we just want all the possible solutions. So our possible solutions could be less than negative 13, or they could be greater than 9. Any of those sets of numbers will satisfy this inequality. Is there any way to combine these graphs or rewrite the graphs together? There's not. The only thing we need to do is give our compound inequality. So we'll say that m is less than negative 13, or m is greater than 9. Questions so far? Let's do one more here. Let's see. Y minus 1, the absolute value of y minus 1 is greater than negative 2. Is this an and or an or? It's or. And how do we know it's or? Or than. So if we set up our two inequalities, we'll have y minus 1 is greater than negative 2, or y minus 1 is less than a positive 2. What would you do to solve?
Add 1.
Good. Add 1. Y is greater than negative 1. On the right side, we can add 1. Y is less than 3. So y is greater than negative 1, or y is less than 3. Let's graph this. We have greater than negative 1, and then less. What's our solution? Why? Yeah, they're overlapping. Not that we care really where they share solutions when they overlap, but their graphs happen to overlap, so they're going in opposite directions, indicating that all the positives, all the negatives, every number is covered in at least one of the inequalities. So I agree. Let's draw a graph that indicates all real numbers. you do need to see that graph that you're representing with all real numbers and the symbol for all real numbers. Indicating that any number we put into our inequality is going to be true.
Would it be all real numbers if both the open circles were on the same line but go different directions?
Good question, it would not be. Because if they both had open circles at the same point, then it would be all real numbers except for that number. So if it
But
happened
if
to
it was a
happen to
closed
be
one, it wouldn't be.
if it was a closed circle, it would be. If one or even both of them were close, it would be real numbers. Alright, I'm going to stop here so you guys have an opportunity to get your homework hopefully done in class. We'll see if you probably get a jump on it. Just remember, we don't really care if they overlap. We want all the possible solutions. Make sure you include your graph in the compound inequality that's describing the graph in your answer. Oops. Let me double check this, make sure this is the right assignment. 4 through 6, 14 through 19, 21, 24, 26, and 20. There's that 26 you guys did last night.
There, no, that variance is 4 through 8, and 4 through 6. 4 through 8.
Well, let me double check.
It's 4 through 6.
You know what? I think it should be 4 through 6.
Yeah, because last night we did 8.
Yeah, I need to change it. It should be 4 through 6.